Okay, guys, welcome back to my Smarter R YouTube playlist. So today I will show you how to map uncertainty in by using R. So we have sometimes we want to evaluate our GCM model, and we want to know which area is our model can simulate better. And to do this, we need to map the uncertainty. So uncertainty can be calculated by using a lot of statistical metrics like NSE, RMSE, p bias, or R square, and so on. So I will show you. Let me share the screen. So we will map everything by using R. So it is easier, it is reproducible, and it's very fast. So let's see. Okay. So this is the code that I have prepared. So we want to map, you see, 20 as uncertainty that I want to map here. It's up to you. If you have more result, then it's better. So for example, we have mean error, mean absolute error, mean square error, RMSE, normalized with mean square error, p bias, RSR, RSD, NSE, MNSE, RNSE, relative uh, index of agreement, modified index of agreement, relative index of agreement, coefficient of data. CP is actually persistent. Persistent. So I think it's coefficient of persistent, persistent, and then R correlation coefficient, R square, BR square, KG, and VE. So first, before you do the uncertainty analysis, you must know the value of each of the metrics. If it's lower, then it's better. You see, mean error, if it is lower, then it is better. And MAE, if it's lower, then it is better. For R square, if it is higher, then it is better. So you must understand the matrix, the value of the matrix. Is it higher, better or not? Lower, better or not? After that, you map it. So without further ado, let's look at the coding here. So you need RGDAL package. If you have problem with RGDAL package because this package is already discontinued, you can refer to my other video how to solve this RGDAL package, and then you can use this RGDAL package, and then you use raster package, SP package, and then R color brewer package. So let's read our dataset because all of this value statistical metrics I already calculated. If you don't know how to calculate it, you can do the calculation yourself, or you can refer to my other video. I show you how to calculate all these statistical metrics. And then let's see our data. So my working directory is ICN sure 2024 mapping uncertainty. So the data that I use is uncertainty for Peninsula Malaysia for this model, CMCC ESM2. So CMCC ESM2 is one of the best model that can simulate rainfall in Peninsula Malaysia. So this is CMCC ESM2. Okay. So you must have your let and long location for Peninsula Malaysia, where the grid point that you have, and then all the value. You see, I calculate all the value actually from ME until VE, all the statistical metrics. I have 20 statistical metrics. All the value is there. So all the value for each grid point. You just take the mean value from temporal one. Just take the mean value for that particular location because we want to do a spatial analysis. So we get our data like this, let long, make sure you have the let and long, and then all the value, other value for your statistical analysis. And then read this data, and then set our working directory for the shape file. So we want one, if we want to map similar with GIS, ArcGIS, and so on, you can prepare this shape file by using GIS first, and then put it somewhere in the folder. So for example, for this one, I put my shape file of Peninsula Malaysia in here. I see ensure shape file for Peninsula Malaysia is here. So put the shape file here. You can prepare it by using ArcGIS or QGIS. So and then put it here. So that anytime in the future you want to do the same place, you just refer to the same shape file. You don't need to create anymore, or don't need to customize everything. So you can do everything in R. Just create the shapefile first, and then put it here. Okay, now we read the shapefile. Shapefile is Peninsula Malaysia. This is fine. You can just copy, and then read it. And then just in case the projection is different for our shapefile, we can reproject it. Reproject. This is actually for Peninsula Malaysia shapefile. So we can use a SP transform to reproject it to WGS84, the common one that we use. Okay, we already reproject it. Actually, I think the original one is uh, already this Peninsula already use WGS 84, but it is better to confirm, because sometimes we use shapefile from our friend that use different projection and so on. It's better to reproject it first. And then we plot the data. So we use a plot map by using function raster data variable name. Then we use a raster from XYZ. So that's why we need our long and let, that long, and then variable name. And then we set the color of our map. For example, we want the red one is the lowest performance, yellow one is the best performance, orange in the middle, something like that. I like this. The color RAM is like this. And then define legend label, and then we plot it. This. So I want to make it easy for everybody can see it later on. Okay. Okay, I put it here so that everybody can see it. Okay, we plot it. Variable names 1981 to 2023. And then we have y-axis, x-axis, and so on. Plot it. And then we can run this plot map. You can run this plot map. And then we can plot everything, all the 20 statistical variables by using plot map function. So for example, I want to do MAE just now, right? So I can just click this one. You see, this is the uncertainty analysis for MAE in Peninsula Malaysia. But actually, I want the red one to be the worst result. So because this matrix, some of it, the lower is better. Like on the lower here, the higher is better. Up here, the lower is better. So sometimes I need to change it again here, yellow. And then this is one is red. So we run this again, and then we can plot MAE. So we can say that MAE, this model is very bad in northeast or eastern area of the Peninsula Malaysia, because this is very high rainfall variability. So the model cannot simulate the rainfall here very well. This is the mean absolute error is about 140. But in the middle here and southern Johor, the model can simulate it very well. So we know the performance of the model good in this central area and the southern of Johor. If we measure by using MAE, and if we measure by using NRMSE, we can see the similar result, more or less similar result, but some quite small difference in term of bordering difference only. But most of the NRMSE is very bad in the east coast of the Peninsula Malaysia. This is for CMCC ESM2 model just now. So some models very good in the central area, because central area here is like forest area. It's not disturbed. So climate may be more homogeneous or something like that. I don't know, but the model can simulate very well the forest area here. And then when I want to do the higher one, I will change it here again, and then let's plot it again. And then for the higher one is better. For example, R square, you can see R square, you can see uh, R square is better in the northeast of Peninsula Malaysia. But in terms of mean absolute error, and IMC is worse. But in terms of R square, it's better. You can see the matrix can give you different result because they have a different interpretation of the result. And then we also have KGE. KGE, you see, KGE also, so the notice is not very good. KGE, very low KGE. And let's see, NSE. NSE is also not very good in the Northeast. So we understand that some model, a lot of the model, even this top model that we already found that this is the top model already, but still there is some special uncertainty of the model. So we, by understand this uncertainty in the model, we understand which, how we can further develop this model, especially in terms of rainfall variability during the Northeast monsoon. We want to improve the model, we must identify the problem first by understand the uncertainty in the model. Uncertainty in the model, we found that the model cannot simulate very well the during the northeast monsoon, during the rainy season, during the high rainfall variability, high extreme rainfall. So the model can be improved in terms of that cases. Okay, I think this code will be very helpful for everybody doing uncertainty analysis. So I think that's all for today. The code is not quite extensive. You can follow this code. If you want to, if you want this code, if you want to collaborate with me, I can show you. Collaborate with me in terms of research. I can share you this code. Otherwise, you can watch this code and try to copy all the line of code here. Thank you for watching. I hope this will be helpful for you.